Hello, this is the sixth video in the series on circle properties. The one that we done, the previous video is also on tangents. So the fifth property and the sixth property both are about tangents. And the fifth property was about one tangent, where remember we have learned one law, and that simply is that the tangent is perpendicular to the radius. So now today we're going to do the law where there is two tangents, and I want you just to remember that with two tangents we basically have two properties. So we will now look at those two properties. So what you must have is an external point, okay? The law is about two tangents from an external point. So you've got the external point and you've got two tangents, okay? From there to there and from there to there. And remember that a tangent touches the circumference at a single point and touches the circumference at a single point. Okay, so the first property states that the tangents, okay, from the touching point to the external point and from the touching point to the external point are equal in length. Okay, so this one and this one is equal in length. So I'm going to say tangent to external point equal in length. Okay, that is the first property that you must remember here. Then the second property is the following. A line that joins the center of the circle to the external point will divide or bisect the angle at the external point. So this angle is equal to that angle. So the second property is simply line from center to external point bisects angle at the external point. Okay, it is a long explanation. However, if you look at the drawing, it is quite easy, isn't it? So you've got your line length here and there that is the same, and you've got your angles here that is the same. I, however, want to also go on a little bit and show you something else which you should realize together with these two laws. So number one, when I draw a line from the touching point to O, then that is the radius, isn't it? And when I do the same on this side, then that is also the radius. Now let's just go back quickly to the law, the previous law of circle properties, where we have one tangent. Remember, when we have one tangent that then crosses or touches, intersects with the radius, then this angle is 90 degrees and this angle is 90 degrees. But what I want you to also now look at, if you look at triangle OP, and let's just quickly call this one X. Look at triangle OPX and triangle OPY. Okay, then you should realize that they have the same side lengths. In this case, it's both a radius. In this case, it is the tangent to the external point, which you now learned the property was that they are equal in length. And line OP is the same for both triangles. Okay, so it has three equal lengths, which means these two triangles are congruent. Okay, you already learned that. Congruent means they are identical. Okay, that also means, people, that their angles are identical. Now, so look at angle Y and angle X. They are both 90 degrees, all right? that is the property of the one tangent. Now, if you look at angle YPO and angle OPX, then they are also equal. This is now the property that you learned now, that this line from the center to the external point bisects this, which now brings us to the conclusion that this angle and this angle must also be the same. Okay, so importantly, what you must realize is that line OP, okay, is a line of symmetry. And a line of symmetry divides this figure OYPX, okay? This is the line of symmetry of this kite. It divides it into two equal triangles. And if we have congruent triangles, then their side lengths are equal as well as their angles are equal. So this is really important for you to remember because it makes the calculations with two tangents to a radius, to a circumference, much easier. Okay, if we then look at the following example, so if you look at it, we've got the circle with center O, we got an external point T, we then got a tangent TA, okay, and we got a tangent TB, right. Now remember from the previous law, immediately you know that AT and BT is of the same length, but you also know that angle OTB, this one, is equal to angle OTA, this one. All right, and if you now look at what the instruction is, which says find x and y, then here already you just simply know that x is 27 degrees because remember this line OT is a line of symmetry. It bisects the angle at the external point. Okay. Also another reason, maybe if you remember that well, if you look at figure AOBT, then that is a kite, isn't it? Okay. And in a kite, one diagonal, okay, which actually goes from that point to that point. So there, where your angles are not the same, that diagonal bisects both of these angles. That's a property of kites, which you should also know. All right, now look at the second one. They are asking you angle Y, right? So angle Y, people, we don't, or let me just see, okay, I'm going to explain to you two different methods in which to explain. The first method, I want to come back to our properties, okay? So now remember, the property says that it bisects the angle at the external point. But I also told you that you must remember that OP, or in this case, OT, is the line of symmetry, which therefore divides angle Y into two equal angles. So angle AOT and angle BOT are of the same size. Meaning if we can get this one, right, then we can actually just multiply by 2 to get Y, right? And this one is quite easy to get because now look again at this line is a single tangent, okay? And one tangent is perpendicular to the radius. So this is a radius. This one is the tangent. So therefore, this one is 90 degrees. Okay, so we have got that as 90. We've got that as 27. And we want to calculate the green angle. And immediately your brain should now go to triangle OBT, where we are going to work with the interior angle sum of triangles, which is 180, isn't it? So angle B, which is 90, plus angle BTO is 27, plus this one, which I made a question mark, equals 180 degrees. Okay? So when you now calculate that, you should get that the question mark is 63 degrees. Right. So this one is 63. So look at angle Y, people. Angle Y is twice 63 degrees, isn't it? And that gives me a size of 126 degrees. So that's the one possible solution. The other possible solution I want to just make you aware of, and that is very much in geometry questions the case, people, that you've got different possible solutions. So remember, this one is 90 degrees, then that one is also 90 degrees because this is also a radius, okay, and that is a tangent, so that's 90 degrees. So this could bring us to the property of the interior angle sum of quadrilaterals, which is always 360 degrees. Okay, and if you take the kite, then Y is being asked, okay, plus we can take angle B, which is 90, plus angle A, which is another 90, plus the angle T here is 27 times 2. No, it's 27 plus 27, okay? And that should give us 360 degrees. And when you now calculate that, you will also get that Y is 126 degrees. All right, so let me just revise quickly. The property that involves two tangents from an external point, okay? Two tangents from an external point. Remember, you must have an external point and you must have two tangents. Then the property says that the line from the tangent where it touches the circumference, okay, to the external point is equal in length, and then also the line that goes from the center to the external point bisects the angle at the external point. And don't forget, the last important fact is that the line from the center to the external point is a line of symmetry, which gives you automatically two congruent triangles, and that means two identical triangles.